Okay, in this video, let's see like in last video, so we have seen distribution and uniform distribution, Bernoulli distribution, and binomial we have seen. So in this video, so we'll see what is normal distribution and what is binomial versus Poisson. So we'll see here. So this is normal distribution, guys. Okay. So in just simple terms, if my data is towards the mean, complete complete my data it's towards to the mean, or if my complete data is in occupies at middle portion, so then I call this is distribution is like normal distribution. Okay, so this is in just simple terms. So just think just memorize, just memorize or just register it accordingly. Without this distribution in machine learning is there are so many statistical tests, everything based on the normal distribution. If my data is normally distributed, then only I can do something. So if my data is not normally distributed, at least there are there are some theorems like a central limit theorem, so I'll make my data normally distributed, then I will do some statistical test. Okay, so that is the importance of this normal distribution or Gaussian distribution. Okay, so in just other in mathematical sum, so if it is normally distributed, my 68% of the data lies in first two segments. So else other 95% of the data is in so that like almost like 95% of the data will be in my first two segments. Okay, so you can just think of it. So that is what, so my complete data will be towards the mean. So this is normally distributed. Okay, so this is what normally distributed. So now we'll see Poisson distribution, guys. Okay, so Poisson distribution, this is also very very important, guys. Okay, so binomial distribution versus Poisson distribution. Okay, so I'll just give the simple analogy here. So to make you understand the Poisson distribution, I'm just correlating with the binomial. So why binomial? Why then polynomial? So the same analogy. Suppose I have a company. Suppose I have a company. Just imagine there is one cave, and here there is a company which worth of employees of 700. Just imagine. So I have a cave. So I know that one in three in three out of one, for sure they are going to come to this cave and they are drinking, just imagine drinking tea. So that means like one out of three in the 700 employees, or so just imagine, let's make it less number so that it will be easy to calculate. So or 75 people, just imagine. So this many employees, so one out of three, so that means like 25 people are coming to my cave or this cave, and they are drinking tea. So now if I want, what is the probability of, what is the probability that 30 people are willing to take tea in this cave, like, or 30 or 40 or any discrete value. If i want if i want to know that probability, and if I want to do some experiment like this kind of, if I want to do experiment like this kind of situations, or this kind of data, so I will go for binomial distribution. Okay, guys. Okay, so here, so this is what binomial distribution, sorry, this is what binomial distribution. So now see the same scenario. So same, so I have company. So suppose, as I said, like, I have a company 75. So now here the experiment what I want to do. So suppose, so here, as I said, like, what is the probability that 30 people willing to come, 40 people willing to come? So that is like discrete values. Okay. So here let's say if I want to know what is the probability that the people like what is the probability, so like as I said, like 1 out of 3 is going to take tea. So now if I want to know what is the probability that people will come from between 10 a.m. to 9 a.m. to 10 a.m. So in between this time period, so what is the probability that employees come and drink tea? So you can see here might be 901, 92, 95, 910, 915, 920. So in between there are continuous values here. So the only one thing we need to understand here is the binomial distribution deals with discrete values. The Poisson distribution deals with continuous values. And this is very important. And if you can say this point, so you are going to hit the interview, okay, for sure. You are successful in that interview. This is very, very important. Understanding this is very important. So when you are going to use this binomial distribution, so when you have discrete values and you have like success or failure, whether he will drink tea or not. So in this case, you will go for binomial experiment, or then what we will get the binomial distribution. So if I want conducting, if I am conducting on continuous values, if I am conducting some experiment on some continuous values, so here I want to know how many will be drinking tea between 9 a.m. to 10 a.m. So here that it may between 9 a.m. to 10 a.m. So like he imagined like 1 to 3, 3 out of 3 he imagined like one. So might be there are chances like two people may in this time maybe entire complete employees may come, entire employees may come. So or might be outside employees like whoever may be like in surroundings, who like other employees may join, and maybe it may reach to 1,000 also, who knows, 1,000 also in between this time frame. So no one knows. So there are very, very tiny chances, very, very less chances. So but that may happen. So in this case, so we are what in this case or in this scenarios, what we are going is this is called Poisson experiment, and we are like distribution called Poisson distribution. Okay, so hope so now have the clear clarity on this binomial versus Poisson. Hope so, and where you can able to explain clearly if anyone asks, or if are in interview point as well. Okay, so for sure if you are going to explain these distribution correctly, you are going to crack an interview and take it granted, guys. Okay, so learn it once again, check the video, so make this analogy and memorize in your register it and memorize it accordingly. Okay, okay guys, chalo then. Okay.